All right, let's get started. On Module 2.1, we're going to take a look today at exponent rules and integer exponents. Now, the exponent is sometimes referred to as a power, but it's not really correct. The power includes a couple of things. Every exponent is the little number up there on top, and it belongs to a base. And together, the base and the exponent, all together, they make a power. And what that exponent tells you is it tells you how many times we're going to multiply any value by itself. Let's take a look at some of these things. You might have already seen some positive exponent rules before. For example, 1 squared, or 1 to the second power, that just means 1 times 1, and that's just 1. And 1 to the third power is 1 times 1 times 1, and that's also 1. But if we jump down to a different number like a 2, where the base is a 2, the exponent here is 2, so it means 2 multiplied by itself twice, and that's 4. And this right here means that we're going to have 3 2's. 2 times 2 times 2, and that's 8. And we jump down to the 3. 3 squared, that's 9. And 3 to the third power is 3 times 3 times 3, which is 27. Now let's go back and take a look at some of these powers that have an exponent of 1. Anytime you have an exponent to the 1, you're just going to end up with that number. So 1 to the 1 is a 1, and 2 to the 1 is a 2, and 3 to the 1 is a 3. Let's back up here and take a look at the 0 power. This is a rule that you need to know, and that is anytime I go backwards in this column, math is a lot of things in math are about patterns. 2 to the third power means 2 times 2 times 2. And 2 to the squared is only 2 2's. And if I take away a 2, it's like dividing by a 2. And 4 divided by 2 is 2. And 2 divided by 2 is 1. And whenever we have something to the 0 power, what we're really saying is it's that number divided by itself. And we just get a 1. Take a look at 27. This was my answer for this problem, and then it was a 9. That's dividing by 3. Then it was a 3. That's dividing by 3 again. And so if I work my way backwards, 3 divided by 3 is 1, and we can come up with an assumption. Anything to the 0 power is always going to be worth a 1. So let's take a look at the negative exponents. Now, negative exponents are different than multiplying. Negative exponents really just mean repeated division. And so 1 to the negative 1 is really 1 over 1, which is still 1. And 1 to the negative 2 is also still 1, and so is 1 to the negative 3. But when we get down to numbers that aren't a 1, we're going to have some things to consider. 2 to the negative first power is really 1 over 2 to the first power, and that's 1/2. And 3 to the negative 1 power is really 1 over 3 to the first power, which is 1/3. And if you take a look at 2 squared was 4. So 2 to the negative 2 is really 1 over 2 squared, and 1 over 2 squared is 1/4. And if we follow the pattern, 3 to the negative second should be 1 over 9. 2 to the negative third power, we can look over here and see that 2 to the third power was an 8. So 2 to the negative third is really a fraction. It's 1 over 2 to the third, which is 1 over 8. And 3 to the third was 27, so 3 to the negative third power is 1 over 27. Notice that negative exponents didn't one time mean a negative number. We still get positive values, but when we have negative exponents, we're just talking about division. Anytime you have a power with a base 10, 10's really pretty easy to manage because the exponent tells you how many zeros you're going to have after the 1. So a 10 to the first is a 1 with 1 0. It's just 10, just like before. We get the same number. 10 to the second power is 10 times 10. Most of you guys know that to be 100. As the exponents get bigger, just look at the exponent. It tells you how many zeros are going to be there. So 10 to the third is a 1 with 3 zeros. And 10 to the 0 is a 1 with no zeros, which is still just 1 and follows the pattern. In fact, all these numbers here to the 0 power are going to be worth 1. It doesn't matter what we have. Any values is going to the 0 power will be worth 1. And if you take a look at the table above, anytime we have that negative exponent, it's going to be written as fractions. So it's going to be the same number, 10, but as a fraction. It's 1 over 10 to the first, which is 1/10. And then this right here is 1 over 100. And 10 to the negative third is 1 over 1,000. Now let's take a look at these the negative bases. What this means is, just like we had before, it still means repeated division, but now it's a -1 in the parentheses raised to the -1 power. And this is where we're going to start to see some problems. I'm sorry, that's not a -1, it's a 1, because I moved it down already, so the exponent becomes positive. And -1 to the first power is -1. So what we end up with is really 1 over a -1, and we know from our integer rules that that's worth a -1. So -2 to the -1 is really 1 over -2 to the +1. Once I move it down, the exponent can change signs, and that's really -2 to the first power is just -2. So we end up with 1 over -2 or -1/2. So we can assume now that anytime we have a negative number to an odd power, we're going to get a negative value. Because take a look at what happens here. This is going to be 1 over -1. Now that I moved it down, it becomes a positive power. And -1 squared means -1 times -1. And we know that a negative times a negative is a positive. So -1 squared is going to come out to be a +1, and that'll give us an answer of 1. And -2 raised to the -2 power will be 1 over, and then a -2 to the +2 power. And -2 times -2 is 4. So we're going to end up with 1 over 4. So these are positive, whereas these over here were negative. And now we're back to another odd power, and you're going to see that we're going to switch these things. We're going to go back and become negative answers. 1 over -1 to the +3 power. And if we follow our integer rules, -1 times -1 times -1, that's 3 negatives. And that's going to come out to be a negative. It's going to be 1 over a -1, and that's just a -1. -2 to the -3 power is 1 over -2. And since I moved it down, again, it becomes positive when it's in the denominator because it was negative up here. And negative times negative times negative is still a negative. And 2 times 2 times 2 is 8. So it's -8. And so that gives me a final answer of -1/8. Let's go over here and finish out the chart. We know that anything raised to the first power is just that answer, that number, that base. That's all we're left with. So that becomes a -1, and that's a -2. And -1 squared is -1 times -1. That's just a +1, just like this is -2 times -2, and that's a +4. And then this is negative times negative times a negative. -1 times -1 times -1. Well, 2 negatives would be a plus, and then the third one makes it negative again. So you can see that anytime I have an odd number, a negative number raised to an odd power is going to give me a negative answer. This one's going to be negative as well. 2 times 2 times 2 is 8, 3 of them. So 3 negative 2's is going to be a -8. Now in the lesson, you have a few examples. I'm going to do the first couple of them for you just to show you what you're doing. This whole thing together is called the power. The base is the little number underneath, so we're identifying the base as a 4. The exponent is a 3. And if I want to write it in expanded form, that just means we're going to multiply 4 times itself 3 times. And 4 times 4 times 4 is 64. Now, I can see from the expanded form here that this is repeated multiplying of a 3, which means the base is a 3, because whatever you see here is the base. And I can see that its exponent was a 5, so written as a power, that would just be 3 to the 5th power.